Welcome to my talk. You have to read 50 different RFCs that contradict each other, where we conducted an interview study with on the experiences of implementing cryptographic standards. Below you can see all of my lovely co-authors without whom this work would not have been possible. But let's quickly start with some motivation. As you heard a bit here, why would we look at cryptographic standards? Because there are a lot of them. And when putting them into practice, there are also many different implementations. So our core question was, how can we improve standard adoption and security? Why is that an interesting question? Let's start with an example. For an example for a cryptographic standard, I took TLS 1.3. You can see it here. This is actually a screenshot of the original RFC. And as it mentions, the document specifies version 1.3 of Transport Layer Security, TLS. TLS allows client and server applications to communicate over the internet in a way that is designed to prevent eavesdropping, tampering, and message forgery. So what that means is that the goal is to enable secure communication and to ensure compatibility between clients and servers that use TLS 1.3. So what do you do if you want to implement this standard? Well, first of all, you read the entire RFC, which are 160 pages. You then, towards the end of the RFC, sometimes in the middle, there are also references to it, find this little table that contains cipher suits that you need to implement in order to communicate. These are actually just a part of it. You then also have to look at the cipher suits. You look, for example, at this funny thing called Cha-Cha-20 and Poly 1305. You implement that RFC of multiple hundred pages. You also implement SHA 256, which is specified here in this FIPS document, which is an entirely different document. You implement all of these cipher suits, all of these parts of the standard, the handshake and stuff, and in the end, you end up at a final first implementation. You then use that implementation to talk to existing implementations, other servers, for example, OpenSSL, the implementations that we mentioned before. It doesn't work at first. You then do some compatibility testing, find out what they do different. And after a lot of time, you actually get a working implementation. So what is that? For the younger people in the audience, that is actually a 1-decade-old work, as I found out, discovered in 2024, that in short allowed clients to ask a server to send all encrypted communication or a lot of encrypted communication that has happened on that server recently. That was a bug in OpenSSL, and if it can happen to OpenSSL, how about your application? To find out, we talked to cryptographic developers. We conducted interviews with 20 cryptographic developers that we recruited from popular crypto projects we selected ourselves, as well as the NIST PQC forum, a forum used for the post-quantum efforts of NIST, and the IETF SAAG mailing list, a general security and crypto mailing list from the IETF. Using these two lists, we actually got a broad sample of demographics. For example, we got both developers with less than 5 and more than 20 years of experience. We got many different project areas, for example, post-quantum cryptography, PGP, SSH, TLS. And we got both open source and industry developers. We actually have a lot more demographics in the paper if you're interested. But let's focus on what we can learn for this talk. So, learning from expert experiences. For this work, we looked at 3 core questions. First, how do developers implement cryptographic standards? Second, what are the typical challenges they encounter when implementing standards? And third, how can we use this knowledge to improve future cryptographic standards? So, since we have limited time, let's zoom in on a few key findings for each of these questions. There are, again, more in the paper. But let's start with key resources that developers use for implementations. First of all, as you already heard in the talk 2 talks ago, they use reference implementations a lot. They mainly use them for overview, according to what they told us. So in order to not have to fully read and understand the 160 pages I previously mentioned, actually, but they use them a lot. The other thing they use a lot, it was actually in my example as well, is third-party implementations, because if your TLS client cannot talk to OpenSSL, you can be pretty sure that nobody will use it. Third, another thing that they use pretty frequently is test vectors in order to test and verify. They either generate them themselves or get them from the standard, and as one participant actually put it, test vectors would be very helpful, test vectors everywhere, but that is not always the case. He was referring to how test vectors and some other of these resources in general are not available, especially for older standards. Yeah, that concludes these findings for now. Now let's look at some of the challenges we identified. First of all, what especially younger developers mentioned, or less experienced developers, I should say, is that complexity of standards invites mistakes. So if a standard has many different variants, you have to choose how to implement all of them. You have to select which ones you actually want. If it has extensions, you have to select which extensions you want. If a standard is very complex, then there's a lot of room for error. Second, something participants also mentioned is that copyright laws and patents always needed consideration. So there's still a lot of copyright and patent stuff going on in cryptography, and there are some weird export laws in some countries that may make deployment of your product in that country actually very hard. Finally, backwards compatibility was actually a hard problem for developers. Here again, a little quotation. As one of them put it, a major killer thing about an update for us is if you have too much trouble with older clients. So if an update to a standard actually introduces incompatibility with the previous version, then that may keep people that actually have clients from even deploying it. With these challenges roughly covered, let's talk about the key aspects for the future of standard. So one thing all participants, or the majority of participants mentioned, is that transparency in decision-making and reasoning for standards is something they desire for the future of all standards. So the IETF and the NIST have actually been working on improving their transparency for their standardization processes. But for both organizations, we actually got feedback that when in detail looked at, not everything is perfect. You can find more on that in the paper as well. Finally, or second, resources and ease of implementation actually make successful standards. So again, especially the younger or less experienced developers that needed to get into the entire cryptography game first, mentioned that they would prefer and select standards that are, of course, easy to implement and that don't make many mistakes for them. Finally, something everyone mentioned was that closed standards lack acceptance. Even the industry people mentioned that if something like a patent prevents standards, then that will close adoption. Or as one participant put it, in general, when somebody tries to patent cryptography, it's actually more of a deterrent than if it was just standardized, made public, and allowed broadly. Okay, with that, with our key findings out of the way, let's look at a few recommendations that our paper makes. First of all, for authors, they should focus on simplifying implementation. That includes providing resources like, for example, simple reference implementations to understand the standard. It includes third-party tracking third-party implementations and providing them. That was something some people found to be nice. And finally, as I mentioned, to provide test vectors for verification. Then, on the other hand, standards themselves should consider having reduced complexity. That includes both having less choices and fewer gaps in standards, fewer decisions for the developers to make. If that is not possible, because sometimes there's a reason for the complexity, then there should be secure defaults and clear guidance on what to implement, what not to implement, what to care for. And finally, standards should always consider what happens when they get updated. Finally, The organizations need to focus on transparency. So the IETF was actually honored for being very open in disclosing law and copyright considerations. They have a little tracker where you can see all the claims that are made towards a standard, and then you can, based on that, decide whether you are allowed to implement it. Organizations should document the decision-making and any updates they make. They should provide reasons for any changes, for any choices that they make, so that developers can actually follow these choices even outside of the pure standard document. And finally, organizations need to get better at involving all stakeholders, especially industry stakeholders and stakeholders that have not been as deep into cryptography yet, reported that they, for example, are scared to contribute to public discussion because that discussion is usually held on a very high standard of cryptography, so it's difficult to interact with. Yeah, these are the main recommendations that I'm gonna introduce for this talk. So this is my summary slide. The key takeaways are listed here as well for your questions and etc. If you have interest in more on that, we have the full paper on our website, including a replication package with all the material we used for the interviews. And yeah, with that, my name is Nicolas Huaman. I will be on the job market actually this winter. If you want to talk to me about cryptography, standards, web security, or usability, you can contact me through any of these channels. Especially my website will always have my updated socials. Before I conclude, I would like to again thank all of my great co-authors without whom this would not have been possible. And you can contact those as well if you have questions. Yeah, so thank you very much.